Hey, good morning, everybody. This is Mr. Ainsworth, and we are going to get into yet another review before our Section 5 test coming up here in a few days. And I think it's important to go over some basic skills here. Now, the portion that we're prepping for is multiple choice, and you either get it right or you get it wrong. All right, there's no partial credit in here, so you got to be really precise and you got to be really prepared, and that's why I'm doing another video here, just again to give you some experience here in between our sessions, because we're online these days, and to get better and to keep your skills up, because it's important to review. And if you're not doing it on your own, hopefully this will give you just a little push in the right direction and help you guys prepare for your test coming up. All right, so let's get started here. Right, now there will be questions throughout the quiz. There will be embedded, so obviously listen closely, work through it here, work at your own pace. You can pause, play, rewind as you will, but there will be questions embedded, so get ready, be prepared for that. All right, but let's go over some concepts here. So let's go over how to multiply and divide numbers in the in trig form. So let's go over first concept: multiply, all right, and divide numbers in trig form. Now this comes from 5e 1, 2, and 3. So if you want to have to take out your notes, there you go. You can research them. You can have them handy here. But basically, if you take any two complex numbers, like the first one here, let's say R1, first modulus here, times cosine theta 1, okay, which is just represents your polar angle there, plus I times the sine of the first angle, which is called theta 1. And let's say your second complex number, we'll call it Z2, and it has a different modulus, so let's call it R2, times cosine of theta 2, it's a different polar angle, plus I times sine of the second polar angle, called theta 2. So if you're given these two numbers in trig form here, you should be able to multiply and divide them, okay? Now, if you multiply them, you take Z1 times Z2, that's going to be equal to R1 times R2 times the cosine of the sum of the angles, okay, theta 1 plus theta 2, you add them, all right, plus I times the sine of the sum of the polar angles, theta 1 plus theta 2, all right. So now if you divide them, that's different, okay. Now if you divide them, Z1 divided by Z2, okay, you take R1 divided by R2, so you divide the moduli right here, all right, but you subtract the polar angle. So this one, what we're going to do is we're going to multiply it by the cosine of the difference, theta 1 minus theta 2, so theta 1 minus theta 2 plus I times the sine of the difference, which is theta 1 minus theta 2. All right, so here, what we want to do, if we multiply here there's a dot, right? So you multiply in here, you multiply the moduli, moduli, and then here, this is this theta 1 plus theta 2, all that means, it means add the polar angles. That's all it means. Easy. Now when you divide complex numbers, you divide the moduli. Easy. Okay, so divide the moduli, and then you subtract the polar angles. So all of this can be referenced back in 5e 1 and 2, okay, because I talked about that. So all we want to do today is just practice, okay? So I'm going to give you a couple polar angles to work with, and we're going to multiply them, and then we'll divide them, and just get, again, some practice. Each one of these is going to be a separate question on the test, and all you have to know is what to do and do it correctly. Use your unit circle when needed, and then you're good to go, okay? So here we go. Let's talk about, let me state the polar angle. So let me play with a couple here. So let Z1 equal to, I don't know, I'm just making up some numbers here, cosine of 100 degrees, all right, plus I sine of 100 degrees. Let the second number be just some different modulus. So let's say it's 4 times cosine of a different angle, okay? This is a different polar angle, so that's theta 1 is 100, theta 2 is 35, plus I times the sine of 35. Okay, now let's multiply them together. So let's find z1 times z2. Okay, so all you do is you take the moduli and you multiply them. Okay, so here they are, 8 and 4 are the moduli. All right, so you take 8 times 4, and then you want to multiply, or excuse me, add the polar angles. And okay, now the polar angles, just so you know, are these right here. There's theta 1, there's theta 2. All right, you want to add them. All right, so 100 degrees plus 35 plus I times the sine of 100 plus 35. You add the polar angles. That's all you do. Okay, so, well, let's simplify. Well, 8 times 4 is 32 times the cosine of 135 plus I times the sine of 135. So notice that I just added the numbers, right? 100 plus 35 is obviously 135. Well, I need to know what that is. So we need to grab a unit circle, unless you have special right triangles. There's a couple different ways, as you guys know, to deal with the trig functions. One of them is using the unit circle, and another one is using reference angles and the 30-60-90 and the 45-45-90. So however you were taught, however you know how to evaluate these, it's all good. Okay, so the cosine of 135 is the x-coordinate, so there's the cosine of 135, and the sine of 135 is the y-coordinate on the unit circle with radius 1. Okay, so let's work with these values here. So we have 32 times the cosine of 135, which is negative rad 2 over 2, plus positive I times positive rad 2 over 2. You want to distribute through, so 32 times negative rad 2 would be negative 32 rad 2, all divided by 2, plus 32 times I times rad 2 over 2. When you divide 32 by 2, you get negative 16 rad 2. 32 divided by 2 is 16, but it's negative right there. Same thing over here. So you get plus 16 I over 2. All right, and that's how you multiply. You simply multiply the moduli, add the polar angles, use the unit circle, and simplify it, and you get it in what's called Cartesian form. My friends, that it will be a question on the exam, okay? So all you have to know is your basic skills, and everything like this we've covered multiple times in the review, in the sessions, in the activities, in the reviews. This is just another review. And again, this all comes from activity 5E 1, 2, and 3. Now let's take a couple complex numbers and let's divide, okay? Let's divide. So let's say that z1 is some different number, so let's just make up a new one here. Cosine of, let's say, 105 plus I sine of 105. Okay, so there's one complex number. The second one, it's going to be different. So let's say it's 5 times cosine of 15 degrees plus I times the sine of 15 degrees. Let's see what happens when you divide. Okay, so let's take z1 divided by z2. Okay, when you divide numbers in trig form, let's go to the top of the screen here. Okay, when you divide the moduli and you subtract the polar angles. It's a two-step process basically. Okay, so let's do that. So let's start off with the moduli, all right, and which are 10 and 5. Okay, and let's divide them. So 10 divided by 5. Ooh, that's hard. Okay, and then we subtract the angles. All right, they're called polar angles, or the arguments, which are 105, all right, and 15. So you take the cosine of 105 minus 15. That's going to be tough. Plus I times the sine of 105 minus 15. All right, I'm going to stretch you guys right here. All right, so all I did was I took the angles, 105 and 15, I subtracted them. That's all I did. And then I took the moduli, 10 and 5, and I divided them. That's all I did. So this is equal to 2 times cosine of 90 degrees. 105 minus 15 is obviously 90, plus I times the sine of 90 degrees. And then you have to evaluate that, right? And so we look at the unit circle, okay? And we see up at the very top is 90 degree angle here. So let's go to the unit circle. There's 90 degrees. And the cosine is 0. So the cosine of 0 degrees is 0. And we look at the y-coordinate, and the sine of 90 degrees is equal to 1. All right? So this right here is 0, and this right here is 1. So this would give me 2 times 0 plus I times 1. All right? And 2 times 0 is 0, and 2 times I is 2I, and 0 plus 2I is 2I. All right? And there is the quotient of the two numbers in trig form. All right, so you simply divide the moduli, you subtract the polar angles, you use the unit circle here, okay, and then you simplify. You just got to get good at that. Okay, so those are going to be 2 questions on the exam, guaranteed. All right, take a look at it here. Again, this all comes from activity 5E, 1, 2, and 3, as I said in the very beginning. Okay, what else? Let's go over some more basics. We learned a lot about complex numbers here, so here we go. Let's go to the next set. Okay, let's go over some basic operations. Okay, I'm talking about adding, subtracting, multiplying, dividing, and also the conjugate. Okay, and one more operation, it's called the modulus. Okay, all of these will be separate questions. 4 plus 2 is 6. There'll be 6 questions here on the test. Okay, so let's go over all 6. So 1, 2, 3, 4, 5, 6. There's 6 operations. 6 basic operations, so there'd be 6 questions at least. Okay, so let's go over the, let's start with adding. Let's just go really basic here. So I'm just going to make up some problems. Okay, so addition. Okay, so if you take 3 minus 8i and we add, okay, negative 5 plus 9i, what do we do? Well, how do we get this? Okay, we're adding. So really you don't need parentheses, so I'm going to drop the parentheses here. So 8 minus I plus, okay, negative 5 plus 9i. I'm going to regroup them, okay? So regroup like terms. All right, why? Because you guys, you were taught from the beginning that you only add real with real. So 3 and then plus the negative 5, that goes first. So 3 plus negative 5. And then you group up the imaginary terms, right? Okay, what are they? Well, there's the minus 8i and the 9i. So you group up those. So minus 8i plus 9i. And then you add the real parts. These are real. This is imaginary. And then when you get 3 plus negative 5 is a negative 2. And a negative 8i minus or plus 9i is just a positive i. So you get negative 2 plus I. And that, my friends, is Cartesian form. Remember, it's always A plus BI, all right? A plus BI, that's Cartesian form. Okay, so you add real with real, imaginary with imaginary. So addition is simple. You simply drop the parentheses, regroup, and simplify, okay? Okay, next, subtraction. So let me make up a number. So negative 7 minus 2i minus negative 3 plus 8i. So when it comes to subtraction, the first thing you do is you distribute through the minus sign. Okay? Distribute first. Don't forget that step, because you'll probably get it wrong. Okay? So I have negative 7 minus 2i, and then I distribute. a negative times a negative is a positive, so a minus minus 3 is a plus 3, and then a minus 8i is a, well, it's a minus 8i. So I distribute first, then regroup, okay? So when you regroup, you take the real parts, negative 7 and 3, and add them, and then you take your imaginary parts and you combine those. So once more, you regroup the real, they come first, and then you regroup the imaginary, they come second all the time, and then you simplify, you get the real, you get negative 4, a minus 2 and a minus 8 is a minus 10, alright, and you get Cartesian form here. Now if I'm going too fast, which I probably am for a lot of people, you guys, this is a video, okay? So, because it is, you pause me and play, pause and play and rewind as much as you want, okay? When I'm working on videos here, I'm just going at my normal speed. Well, I'm actually going slower than my normal speed because I have to write all this stuff, and I have to also write all the directions. If I was going at my pace, I'd be going twice as fast at least, or faster, okay? So, use your video to your advantage, all right? Okay, now let's multiply here. So adding, subtracting, multiplying. So let's take negative 8 minus 3i times 2 minus 4i. I don't know, just I'm making up numbers here. Okay, so here we go. Now multiply using FOIL or distributive property. Nothing new. We've been doing that since, I don't know, probably 8th grade. So when you started learning Algebra 1. So negative, okay, so negative 8 times 2 is negative 16. Negative 8 times negative 4i is positive 32i. And then negative 3i times 2 is negative 6i. And then negative 6i times negative 4i is positive 12i squared. Now be careful here because you got an I squared, and remember I squared is equal to negative 1. You guys know that. So really this is equal to negative 12 right here. 12 times negative 1 is negative 12. And when you combine that with the negative over here, the negative 16, that's going to, well, it's going to be a bigger negative. So 32i minus 6i is a 26i, so plus 26i here in the middle. This is going to become a negative 12. But again, you combine the negative 16 and the negative 12 and you get a negative 28. And then plus your 26i. Okay. So again, you get multiply, guys. Multiplying is like really critical skill. It's going to be important when you divide too, believe it or not. Watch this. So when you divide, you have to use a conjugate. So divide. Okay. Key concept here, you have to use the conjugate. Okay. So here we go. Let me make up a problem here. So let's take, I don't know. Let me just look at something real quick. So how about 4 minus I divided by 2 plus I, okay? Something like this. So you have to use the conjugate of the denominator. So the conjugate of 2 plus I is 2 minus I. All you do is change the sign of the imaginary part from positive I to negative I. That's all you do. The real part stays the same. But you got to multiply it in the form of 1. And because these are binomials, you have to distribute. So here we go. So 4 times 2 is 8. 4 times negative I is negative 4i. And then you got to distribute the I here. So negative I times 2 is negative 2i. And then negative I times negative I is positive I squared. Down on the bottom here, again, 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is 2i. And then I times a negative I is negative I squared. Or, if you guys were insightful, you could use structure a plus b times a minus b always equals a squared minus b squared. It's called difference of squares. So if you went 2 squared minus I squared, you can get the same result as I did right here, because the middle terms cancel out. These right here cancel out. And the minus I squared right there, that becomes just a plus 1 with the 4, which will become 5. Okay, and over here on the left, that's 4. Oops. Okay, 4 plus 1, and that will give you 5. So the denominator is 5. Okay, I'm going to put a 5 there. 4 plus 1 is 5. The minus I squared is a 1 added to the 4 gives you 5. Now these guys give you negative 6i here in the middle. This gives you negative 1, and 8 minus 1 is 7. The middle terms add up to a negative 6i. So the only thing you have to do here is divide both by 5, and so you get 7/5 minus 6i/5. Okay? Or you can write it as 7/5 minus 6/5 times I. It's the same thing. Okay, that's Cartesian form. Okay, so you have to be really good at multiplying. You know, all of these will be separate questions on the exam, you guys. I'm talking about your test right now. Okay? There'll be one of each problem that I give on here, which, believe it or not, comes from the review. I mean, the main review that I posted in Canvas already has all of these problems. You can guarantee yourself that there'll be everything on the exam here. Okay? Now, let's do something a little bit easier than this one here. Let's suppose I divide, I don't know, I'm just going to make another one. 20 divided by 7i. I don't know, something like that. And I want to simplify and get in Cartesian form. Simplify into Cartesian form, okay? Because this is not in a plus bi form, okay? Got i's in the denominator, and that's not what Cartesian form is all about, okay? So we got to multiply by the conjugate of 7i, which is a negative 7i in the form of 1. Okay, we practiced this in class last week, but again, we're testing this week, so I thought it'd be important for you guys to review. So 20 times negative 7i is negative 140i, and then 7 times negative 7 is negative 49. I times I is I squared. Then you simplify that, you get negative 140i up top. Negative 1 times negative 49 is positive 49. And there we go. You get negative 140i 49ths, which I guess you can write like this too. Okay? It's the same thing. These are in Cartesian form. It's pure real. Pure imaginary. Okay? No real part. It's only an imaginary part. So that's something simple. Even multiplication, if I give you something like this, I don't know, I'm just making this up. 8i times, let's say, negative 9i, something like a product. So instead of dividing, we multiply. You simply take 8 times negative 9, which is negative 72. I times I is I squared. Negative 72 times negative 1. Remember, I squared is just negative 1. Is positive 72. So this one's pure real. So it depends on what you're given. Are you adding, subtracting, multiplying, dividing? Sometimes they end up being a little bit of real and imaginary both, like a complex number, or sometimes it's pure real, which is still complex, but it's just pure real, like in 72. Sometimes it ends up being pure imaginary, but they're all complex numbers, okay? Because whenever you take a real and add it to an imaginary, you get a complex number, which is in the what's called Cartesian form, right? A is real. It could be 0, okay, which means it's pure imaginary. Or B could be 0, which means it's pure real. But in other words, if you take a real with imaginary and add or subtract them together, you get a complex number. Every number that you know of is complex, by the way, because it's either real, imaginary, or a little bit of both. Okay? All right. Let's continue here. Okay. What else do we need to do? We need to cover, the modulus. Okay, I covered the conjugate, I covered the operations, let's cover the modulus. Okay, now the modulus are, radius, modulus, same thing, or denoted by the absolute value of z, where z is your complex number. is given by the square root of a squared b squared, as you guys know. This is the distance, all right, from the origin, all right, to the complex number. Keyword distance, okay? So, let's calculate it. So if, all right, if I give you a complex number like -3 plus 4i, let's say. No, actually, let me change that up. -6 plus 8i, let's do that. Okay, then the absolute value of z, which is denoted by the modulus, okay, is found by taking the square root of -6 squared plus 8 squared. So square root of 36 plus 64, and that's a square root of 100. In this case, it's 10. So in this case, the modulus is real. All right, I mean it's rational. Excuse me, I didn't mean to say that. So it's 10. All right, it's sometimes sometimes it's a root. So let me make up another one. If z, let's call this one z1 and this one z2. So if z2 is equal to -5 plus 5i. Okay, this one's not rational like the previous one. Okay, then what is the modulus? So the absolute value of z2 is equal to the square root of -5 squared plus 5 squared. And what is that? Well, let's simplify it. Let's take the square root of 25 plus 25, and I get the square root of 50. But what's that? Well, I know that 50 is 25 times 2, so this is root 25 times root 2, which is 5 rad 2. So sometimes it's rational, sometimes it's irrational. Okay, root 2 is irrational, as you guys know from previous units. Okay. All right, so we went over, let me see, multiplying, dividing, and in dividing we talked about the conjugate, so you should know what the conjugate is. That's involved in the test. Ooh, I know. Basic skills. Let's go from trig form to Cartesian form. So trig form to Cartesian form. Okay, what do I mean? Okay, z is equal to r times, actually, not trig form, let's go polar form. That'll cover everything. So polar form. Polar form, there we go. So r comma theta to Cartesian form a plus bi. That will cover trig form as well. Okay, so here we go. There will be a couple questions like this. One calculator base, one non-calculator base or unit circle base. So let's do the a unit circle representative. Okay, so let's suppose that we have if r is, I don't know, 6 rad 3 and theta, let's pick a value on the unit circle like 5 pi 6. Okay, so r, the radius or the modulus, is 6 root 3. Polar angle or the argument is 5 pi 6. And we got to get it in Cartesian form. Okay. So if you look at the unit circle here, you understand that this is quadrant 2. Okay, so let's write it in trig form. So z is equal to 6 rad 3 times cosine of 5 pi 6 plus I times the sine of 5 pi 6. Basic skill. You got to be able to go from polar form to trig form. Okay, so this is trig form right here. All right, now we have to get to Cartesian form. So what is this? This is a quadrant 2 angle, but what is the sign? So let's grab the unit circle. All right, this is how, again, there are different ways to do this. I just tried to make it easy on my students by giving them the unit circle resource, but you could use special right triangles and reference angles to do this. Okay, so there's more than one way to do this. Because personally, I don't really use the unit circle. I just use reference angles and special right triangles, but that's okay. Everybody can be taught in multiple ways. So again, let's go here. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then you got 5 pi 6, which is your quadrant 2 angle. And again, the cosine is the first coordinate. All right, the sine, which is the second coordinate. So I know that I have 6 rad 3 times the cosine of 5 pi 6, which is negative rad 3 over 2, plus I times the sine of 5 pi 6, which is the second coordinate, which is only 1/2. All right, so this right here is negative rad 3 over 2, and then the sine of 5 pi 6 is simply 1/2. So I just took the drawing here and applied it. Okay, I took the unit circle and applied it. You have to learn how to use a resource like the unit circle. And now you distribute. You distribute twice. Okay, so what is the number here? So I got 6 times negative 1, which is negative 6, times rad 3 over 2, plus 6 rad 3 times I, times 1/2. So we have to simplify. So I multiplied both of them by the 6 rad 3. That's called distributing. And then you simplify. So negative 6 divided by 2 is negative 3. 3 times 3 is, root 3 times root 3 is root 9. And root 9 is just 3. So I got negative 3 times 3. And then 6 divided by 2 is 3 here. So I get 3i rad 3. Put the I in the middle, okay? So you don't get confused with the root 3. So this is obviously negative 9 plus 3i rad 3. So you need to be able to go from polar form to Cartesian form. And you have to use the unit circle here, okay? So at this point right here, this is where we use the unit circle. And again, this is what we've done throughout the lessons. This is nothing new. We've done this multiple times. You just got to get good at it. And to get good, you have to practice. And that's the whole idea of studying and preparing. You can't be weak when you come to a test. You got to be able to dominate. All right? And so you guys have got to be good. You should be able to do this problem, if you're really good, in under 2 minutes. All right? Less than or equal to 2 minutes. If you know what you're doing. That's your time goal. Okay? If you're good. And if you want to get an A, you better be that good. All right, now let's do let's see here. Let's reverse it. Yeah, you got to be able to reverse it. You have to go from Cartesian form to polar form and to trig form. So let's reverse the process. So let's go from Cartesian form, which, as you guys know, is a plus bi, to trig form. Ooh. Okay, which is z is equal to r, all right, times cosine of theta plus I times the sine of theta. All right, so that's the reverse process. Now this right here is activity 5D1. Okay, parts 1 and 2. Okay, so if you want to use your resources, use your resources. Okay, so here we go. Let me make up, let's do a calculator example, and then we'll do a non-calculator example. And then I think we'll be done with the review here. So we'll do 2 more problems, okay? Okay, calculator example first. So let's take a complex number in Cartesian form, and let's say that it's let's take a negative rad 3 plus 2i. There we go. No, switch that, excuse me. Let's try a negative 2 plus rad 3. Yeah, I think this will work. Okay. So let's suppose we end up with, we start off with this. So this is our complex number in Cartesian form, and we want to get to trig form. So we got to find the modulus first. Okay, so let's do that. So r is equal to the square root of negative 2 squared plus root 3 squared. So that's the square root of 4 plus 3, or root 7. So the modulus is root 7. Now the polar angle, or what's called the argument theta. Okay, we know that tan theta is equal to rad 3 over 2. Well, we know it's b divided by a, and we know that a is negative 2 and b is root 3. So in this case, it's root 3 divided by negative 2. Okay, so given that, we know that theta is the inverse tangent of negative rad 3 over 2, whatever that is. So you can get that by looking at your reference angles and your 30, 60, 90 triangle, or you can use Desmos, which we use in this class. So let's use it, okay? So let's get Desmos going here, and let's take the inverse tangent of this, and then we'll graph it and make sense of it. So using Desmos here, we're going to take the inverse tangent of negative rad 3. Okay, get out of the root there by using your right arrow key, and then divide it by 2, and you just type it in. Oh, you know what? Oh, shoot. This is a calculator problem. Oh, what I was thinking. You know what? I was thinking of root 3 over 1. That's why I should have made that root 3 over 1. Sorry. Okay, so this is a calculator example. Okay, it's okay. I'll do a non-calculator example after this. I should have made this negative 1 plus root 3i, but that's okay. This is calculator required now. So we're going to go back to Desmos here. I apologize. It's getting too late here. I shouldn't be doing videos at night. Okay, now this is negative 40.9 degrees. Okay, we're going to round it to the nearest tenth. So negative 40.9. So let's bring that in. So negative 40.9 degrees. And because of the negative angle here, this is a clockwise rotation. So let's go ahead and sketch this here. So if you're going to graph this, okay, negative 2, you're going to graph negative 2 comma about 1.7. Root 3 is about 1.7. So you go left 2 units and up, not as far. So left 2, up root 3. You're about right here. Okay, you're in quadrant 2. Okay, and theta happens to be a quadrant 2 angle. Okay, now we want theta. It's between, let me see, this is 0, 90, 180, this is 270, and then back to 360. Okay, so theta is between 90 and 180. Now the calculator gives us negative 40.9 degrees, and that's a clockwise rotation, and that, my friends, is in quadrant 4. So it's actually here. This is negative 40.9 degrees. It's quadrant 4 angle. We want theta. Now we do know that these angles, okay, this one here, this theta's in green now, okay, and this angle here, this is this one in blue, this negative angle, negative 40.9. We know they're supplementary. We do know, all right, okay, that supplements add to 180. They're supplementary. Okay, so all you have to do is take negative 40.9 and add it to 180 to get the theta. All right, so we just add 180. Okay, and then you just get a result here. Okay, so here we go. So let's take a negative 40.9 and then add it to 180. All right, and you get negative 139.1, which is obtuse. It's between 90 and 180. That makes sense. Okay, so 139.1 degrees. That's your theta. And that, my friends, is in quadrant 2, and that makes sense according to the diagram. Okay, so now I started off with a trig example here, meaning it requires a calculator. So trig form, let's finish up. Okay, z is equal to, okay, you got a modulus here, and we got our polar angle here. So root 7 times cosine of 139.1 degrees plus I times the sine of 139.1 degrees. And that is trig form. And this one here is calculator required. Okay, I chose the wrong starting. We started off with this complex number here. I chose the wrong value. I should have made the first a value negative 1. So let's change it to negative 1. Let's do a non-calculator value. Okay. So last example, and then we are done. So let's start off with z is equal to 1 minus root 3i, okay? And let's go through this one. Okay, so this right here, let's go ahead and sketch it first. Where is this? Well, root 3 is about 1.7, so we have to graph 1 comma negative 1.7. So if we do that and we just sketch it, we got to go 1 to the right and then down 1.7, which is further. So 1 here and then root 3 here, which is about 1.7. You're about here. Now theta is always measured counterclockwise from the real axis, so theta is here. Now you always start at 0 degrees and start counting counterclockwise, so 0, 90, 180, and then 270, and then back to the real axis, or 360. So theta has to be in quadrant 4 here, and it's got to be between 270 and 360. It's a big angle. Okay, so let's figure out what it is. So first, the modulus. So r, or the absolute value of z, is equal to the square root of 1 squared plus negative rad 3 squared. Okay, and that's going to be 1 plus 3. The square of a negative is positive, and the square of root 3 is 3. So r is equal to root 4, which means r is 2. So this is 2. And this right here is a famous triangle. This is the 30, 60, 90. So this angle here is 60 degrees, and this is 30 degrees. This is your famous 30, 60, 90 triangle. Now, we talked about this in activity 5D1. So I challenge you guys to take your notes out, because we dealt with this situation. This is no calc required here. We can figure this out, okay? So no calc required. So what would this be? It's not, theta can't be a full revolution or 360 degrees. It's short 60 degrees, or you got to back up 60 degrees. Or you can think of it as 270 plus, this little angle right through here, which has got to be 30. So what is 270 plus 30? Well, you figure that out, right? Or you can take, you can use your trig though. I suppose we could. So you could do this. Tan theta is always b divided by a, which in this case, a is 1 and b is negative rad 3. So negative rad 3 over 1, or negative rad 3. Watch what happens when we use the calculator, just to verify here. When I say that, when we take the inverse tangent of negative rad 3, I bet we're going to get a negative 60 degree angle here, because that's a 60 degree angle, but it's rotated clockwise, so it's got to be negative. So watch what happens. When I go to the calculator here and I enter an inverse tangent of negative rad 3, so type in minus root 3 and then hit the equal sign, notice you get negative 60 degrees. Alright, so this is negative 60 degrees, but then again, this is clockwise, right? So that angle inside that triangle has to be negative 60 degrees. But theta is a positive angle rotated counterclockwise, okay? Remember, this is counterclockwise, CCW, all right, from the real axis here. And so what we have to do is we have to add 360 to this. So theta is really 360 minus 60, or 300 degrees. It's got to be between 270 and 360. So now we are done, okay? We write the trig form. So z is equal to r, which is just 2. Theta is 300, right? So 2 times cosine of 300 degrees plus I times the sine of 300 degrees. Now, I did not need to do this, okay? We used Desmos to verify that, but I knew it was a 30, 60, 90, because if you look at the sides, 2, 1, root 3, you know that this triangle is a 30, 60, 90, because every 30, 60, 90 right triangle has a ratio of sides 2, 1, and root 3. Okay, so you can do things different ways. All right, so in this example, we went from Cartesian form. This is Cartesian form here. A plus bi. Okay, Cartesian form. And we went to trig form. Okay, this is trig form. In the previous example, we did the same thing. Okay, we went from Cartesian form to trig form. And we went through a lot of different examples. In the previous one, we went from polar form to Cartesian form. Well, polar form to trig form to Cartesian form. So we went forward, backwards, we did everything. We talked about the modulus today. We talked about the conjugate today. We talked about how to divide. We talked about how to multiply, subtract, add. I also talked how to add and subtract numbers in trig form, okay, which goes back to 5e, 1, 2, and 3. So you guys, this is a pretty extensive review. So hopefully you appreciate it, and hopefully this helps you get ready for your exam. And I'll see you on test day. Bye-bye.